Hey everyone, it's Justin again, back for another lesson on exponents and another level of power play. In our last lesson, we harnessed the might of multiplication and proved ourselves to be proficient masters of the product of powers property. In this lesson, we're tackling level 2, quotient of powers. Before we jump into level 2, there's a discovery activity in your PDF that we need to discuss first. Pause the video here and complete the activity now if you haven't already. In this discovery activity, we have expressions with exponents being divided. Based on the completed example, I see that first, each exponent was fully expanded, then some of the factors were crossed out. That must be because any value divided by itself equals 1. So 2 divided by 2 just equals 1. In each instance when there's a 2 divided by a 2, the result would actually be multiplying by 1, and anything multiplied by 1 equals itself, which is why removing them from the expression doesn't change the overall value. After canceling out all the pairs of 2 over 2 that make 1, the expression was rewritten with all that remained, which is just 2 times 2. The next column asks how many times the base is being multiplied in the remaining expression. Well, after canceling, all that was left was 2 times 2. So the base is being multiplied 2 times. So it makes sense why the example has 2 to the power of 2 in the last column. If you had trouble completing the discovery activity before, now would be the perfect time to pause and try again. Once you've completed the activity, feel free to pause here if you'd like to check your work with mine on the screen. How about those reflection questions? Did you notice anything interesting about the exponents? Did you make a prediction about which operation is used in the quotient of powers formula? And why did that y cubed end up at the bottom of a fraction? You know what? These are all great questions, and I'm sure you have some fantastic thoughts. I have an idea. Why don't we test our luck in level 2. I have a feeling the answers to our questions may be hidden within the wonderful world of power play. Welcome to level 2. To make it through, you must simplify expressions by conquering the second of the 5 key properties of exponents, the quotient of powers property. Expand and simplify the expressions below. If done correctly, the quotient of powers property shall show. Ooh, fun! A little mystery. Okay, so we have 8 to the power of 7 over 8 to the power of 5, and 8 to the power of 5 over 8 to the power of 7. The instructions say to expand and simplify. Pause here to expand the first expression, 8 to the 7th over 8 to the 5th, in your guided notes. Eight to the power of 7 is the same as multiplying 8 by itself 7 times. And 8 to the power of 5 is the same as multiplying 8 by itself 5 times. Then to simplify, we can cancel out pairs of 8s, because every time we have 8 divided by 8, it equals 1. Everything in the denominator canceled out, so we're left with 8 times 8 in the numerator. And since 8 is being multiplied by itself 2 times, we can rewrite the expression as 8 squared. Now, you try it by yourself. Pause here to expand and simplify 8 to the 5th over 8 to the 7th in your guided notes. This time we have 5 8s in the numerator and 7 8s in the denominator. After canceling out the pairs of 8s, we're left with 2 8s, or 8 squared, in the denominator. Because there's nothing left in the numerator, and each 8 over 8 that we canceled out equals 1, we're left with just 1 in the numerator for our final expression of 1 over 8 squared. How come one of these answers ended up as 8 squared and the other ended up as 1 over 8 squared? What was different about their original expressions? Oh, it must have something to do with where the higher exponent is. In the problem on the left, the higher exponent was in the numerator, which meant that the 8s left over after canceling were in the numerator. And in the problem on the right, the higher exponent was in the denominator, so after canceling, the remaining 8s were in the denominator. Once I input these answers into the game, I think it's going to tell us the formula for the quotient of powers property. But before I do that, pause here and make a prediction in your guided notes. What do you think the quotient of powers property is?
When a is greater than b, x with some exponent a divided by x with another exponent b can be simplified to a single instance of x with an exponent of a minus b. When a is less than b, the expression can be simplified to a single instance of 1 over x with an exponent of b minus a.
Okay, that was a lot at once. And it's totally okay if your prediction wasn't that in-depth. Let's break it down. If two elements with the same base are being divided, we can rewrite them into a single power by subtracting their exponents. But like we saw in the previous problems, the element with the higher exponent determines whether the simplified term is in the numerator or the denominator. If the exponent in the numerator is larger, then the new single power will be in the numerator. If the exponent in the denominator is larger, then the new single power will be in the denominator. Genius. Okay, next problem. We have c to the 5th, d to the 2nd, over c to the 8th, d, e squared, and we need to simplify as much as possible. The quotient of powers property tells us that when two elements with exponents are being divided and they have the same base, we can rewrite them into a single power by subtracting their exponents. Keep in mind, whether the simplified component ends up in the numerator or denominator depends on which element has the higher exponent. Starting with the c's, c to the 5th and c to the 8th are being divided. So we can simplify these components by subtracting the exponents. Based on these exponents, will the final c component be in the numerator or the denominator? C to the power of 8 has a larger exponent than c to the power of 5, so the final component will be in the denominator. Subtracting the exponents, 8 minus 5, gives us c to the power of 3 in the denominator. Try to finish simplifying the rest of this expression. Remember, when in doubt, expand it out. If you get stuck, expand the exponents out and cancel out the pairs. Pause here and we'll check your work when you're done. For the d components, there are two d's being multiplied in the numerator, and even though there's no exponent with the d in the denominator, there is one d and an unwritten 1 as the exponent. The larger exponent is on top, so we can subtract 2 minus 1. And the final component, d to the power of 1, or just plain old d, will be on top. Finally, the e's. We have e squared in the denominator, but no e component in the numerator. Because there's only one instance of the e component, there's nothing to simplify here. We could just keep e squared in the denominator as is. That makes our final simplified expression d over c cubed e squared. Okay, last problem. We need to simplify the expression as much as possible. The expression is j to the 5th times k to the 4th j to the 3rd over j to the 6th k to the 5th. According to the quotient of powers property, when elements have the same base and are being divided, we can subtract the exponents. But right off the bat, I noticed that there's two components with j in the numerator. So which one should we use to subtract? Oh yeah, we're simplifying. So when there's multiple exponent properties at play, we need to keep the order of operations, also known as gems, in mind. The grouping of this numerator needs to be simplified before we can tackle the division between the numerator and the denominator. What property do you think we'll need to simplify the numerator? Since this whole section in the numerator of the expression involves multiplication, we can use the product of powers property. Pause here to use the product of powers property to simplify the numerator of the expression. If we rearrange the expression to put the like bases next to each other, then we have j to the 5th, j to the 3rd, k to the 4th, with the denominator unchanged. Using the product of powers property, we can combine these j's so we end up with j to the 8th, k to the 4th, over j to the 6th, k to the 5th. Now we're ready to utilize the quotient of powers property. Pause the video and try to finish simplifying this expression the rest of the way on your own. According to the quotient of powers property, I can take the two elements with a base of j and subtract their exponents. The larger exponent is in the numerator, so after subtracting 8 minus 6, the final element, j squared, is in the numerator. For the k's, the larger exponent is on the bottom, so we'll subtract 5 minus 4, giving us a final exponent of 1 in the denominator. And since there's only one k, we can record it as just plain old k, making our final answer j squared over k. Remember, you can always expand the exponents to check your work. Yeah, level 2 complete. Now is the perfect time to revisit those reflection questions on the quotient of powers discovery activity. Pause here to review your thoughts and add information as needed. The first question asked which operation you thought would be used in the quotient of powers property. And now we know that when elements of the same base are being divided, we can subtract their exponents. The second question asked why the simplified version of y squared over y to the 5th ended up as a fraction. Now we know that because the exponent in the denominator was larger, the final element will remain in the denominator. Now that the discovery activity is complete, all that's left is to finish your guided notes and then the online practice. I'll see you back here soon when we get ready to tackle level 3 of Power Play. Until then, keep practicing so we can harness the power of the power. See you next time.